Hey, it's Joe, graybenchelec. Welcome back to the bench. So this is part 2, and hopefully only part 2 of the Reeves Electro Zo build series. In part 1 last week, we looked at the Reeves Electro Zo circuit best as I could trace it from the pictures I saw. We compared that to the original circuit, which was the John Hornby Skewes Zonk 2, Zonk Mark II, which is a dual silicon transistor fuzz. We looked at the different component values that Reeves was using in their pedal versus the original Zonk circuit. We also took that and threw it in a breadboard and played around with some different transistors, played with some different value capacitors and resistors for biasing the second transistor. So in this video, hopefully we will try and actually recreate that pedal. If you're familiar with Reeves Electro pedals, you'll know that they are both expensive and really hard to get. They sell out extremely quickly. And so this video is all just about recreating one of those at home in my shop, DIY. So I've already got a bit of head start. The enclosure here is a standard Tata 125B size enclosure. The inside has been painted, as you can see here. This is like a standard brown metallic spray paint I got at a regular hardware store. If you look through Reeves' catalog, you'll notice that most of their pedals, if not all of them, have painted interiors. And on first consideration, this might just seem like an aesthetic choice, but I believe it's actually being used as insulation for the components inside. There's a lot of bare leads flying around on these pedals, and it could be bad to have any of those touch the enclosure. In this case, the bus wires here are ground, so touching the bare enclosure wouldn't be that big of a deal, but the components themselves have exposed leads, and for a different circuit design, you might have bus wires that are for the power rail, and if that were to touch the enclosure, you're now shorting out the power supply. So painting the enclosure to provide you some electrical insulation so that these bus wires, just in case the pedal gets dropped or whatever, if they happen to touch, it won't cause the pedal to maybe at best sound weird or not work, or worse, actually damage the pedal. So I've got the 3 potentiometers installed. A quick note on that, Marcus Reeves was nice enough to reach out and provide some values for the potentiometers that I didn't have in the previous video and got wrong in my assumptions. In the part 1, we used 50K for the drift knob and a 500K volume pot or swell pot. Marcus clarified that he actually uses 500K for the drift and a 25K for the swell. So I've updated the values to match what Reeves uses for their Zo builds. He didn't mention any change to the texture knob, which I finally looked that up, the name of that knob. Didn't mention any change to the value of the texture knob at 10K, so I'm assuming that one's correct. So anyway, thank you to Marcus Reeves for reaching out and offering those values. He also reached out via email and offered any help, so hopefully I won't need it, but we'll see how it goes. So you can see I already have some work done. I've got the pots installed, I got the foot switch installed. The bus wires, I have a couple pieces here. The way that I created these bus wires was taking a picture of the Zo that Reeves has on his website and then bringing it into Photoshop and scaling it 1:1 to the measurements of a 125B, printing that out, and then I sort of have a template of what those bus wires need to be shaped like. The downside of that is as you're looking at it, the picture can only express 2 dimensions, right? Width and length, where the pedal, of course, is 3-dimensional. It has depth to it. And so when you're looking down at this bus wire, it comes here and then bends around to the switch. But the switch is taller than the drift knob. And so the bend here, the radius actually has to be wider than it looks from this angle. And so I initially made that too tight of a bend and then had to widen that out, but still keeping it looking round. The second wire here, this one is all the same Z-axis essentially. There's no change in the depth direction, and so that one was pretty 1:1 to the picture. It gets pretty tight here where it moves between the knobs. I'd have to look at the pictures closer. It might be the case that this is actually closer to the ground and then comes up to meet the DC jack here where I have it all on the same plane essentially. And so I might come in here and just put a little dab of silicone between the bus wire and the pots. 1, to give it a little more rigidity, and 2, to prevent the bus wire from touching the pots. Again, these bus wires are ground, so it shouldn't matter, but it might just be one of those things I do to make me feel better about it. You can also see I'm holding up the bus wires here with poster tack. This was a tip that Marcus gave me in his email, but it's also something I've been doing for a while. I think I originally got this tip from Rollywow from their Queen of Bone project. And yeah, poster tack or blue tack is awesome for temporarily holding components in a specific place. And especially for bus wire here, it not only holds it up in a specific fashion, a specific height, and holds it in place, but it also prevents the bus wire from rotating. If you try to hold this wire in like needle nose pliers, you'll find you can hold it height and, position-wise fine, but the bus wire will actually just rotate in the jaws. Not to mention you're marring up the plating on the wire. With the poster tack here, it's non-marring, it holds in position, and it's sticky, so it doesn't rotate either. So yeah, we're using bus wire to hold this in place, and then once it's soldered, you just pull the poster tack out. So we're going to be using the poster tack extensively to hold up different components. As far as component choices, there's extra conditions to be met, I guess you could say, for building like this. You'll notice in Reeves' builds, he uses a lot of high wattage components or high voltage capacitors, where for other builders, that seems to be just a mojo thing, kind of just playing back into that like vintage tube amp look or feel. But for building in the point-to-point or dead bug style here, using high wattage components actually has an added benefit of coming with heavier gauge leads on the component. And what that will do is when you build it, because the leads are actually a heavier gauge, the whole thing is going to be stiffer and stronger. There's no reason electrically why you couldn't use 1/4 watt or even 1/8 watt resistors in a fuzz pedal like this. The currents flying around are in the microamps, but the leads on those low wattage resistors are tiny. They're like 26, 28 gauge, whatever. And they're just not very structurally, mechanically strong. Whereas for 1/2 watt or 1 watt resistors, I think these are 1/4 watts and 1/2 watts, the leads are actually thicker. I don't know exactly what gauge these are. Yeah, these are like 18 gauge leads on this component, and those are going to be stiffer when they're built into the pedal. And so for this style of building, using heavier wattage components actually has some added utility in that the whole thing will just be structurally more sound because of the heavier leads that tend to come with higher wattage components. So anyway, for component choices, you can see here I have a bunch of these carbon comp. These are the Allen Bradley style, or the flat-sided, smooth body resistors. These aren't all Allen Bradleys. A couple of companies made them that look like this, but that's how they're referred to now, as Allen Bradley style. For capacitors, I have what I believe is the same type of capacitor that Marcus Reeves used in his pedals, is a Vishay. This will be the input cap, the 10 nanofarad input cap. And this is a Sprague 25 microfarad. It's a 22 in the Reeves pedal, but you know, a couple extra microfarad doesn't matter. Also, the tolerances on electrolytics are pretty wide, so the number that's written on was really just a suggestion. For the output cap, I didn't have, I think Marcus Reeves uses the JB capacitors, which are a capacitor, I believe, a Korean-made capacitors. I don't have any of those, but I did happen to have one of these, which is a Siemens-made 10 microfarad at a whopping 630 volts. Obviously not getting anywhere close to that in terms of voltage through that cap, but the look and the feel and the axial build are correct for what we need here. And the leads, while not as thick as they would have been on different style capacitor, in this case, with this pedal, it only really needs to hold itself up, so it should be fine. For 1/4 inch jacks, I'm using Switchcraft. I believe these are number 11 or something like that. Open frame jacks. I don't have any of the style that Reeves uses in his pedals. For transistors, we're using the Teledyne T3416s we were breadboarded with. These are the higher HFE ones. I think they're like 180-ish each. For the LED, I have chrome bezel here. I haven't picked out an LED color yet, but probably just use, I think Reeves uses just a white one, so probably will do that. And yeah, we got the alpha pots in there. The switch is the Gorva switch from Love My Switches. And the enclosure I said is Tata. So these are the components. We're going to start putting it together. I'm going to solder in the bus wires first, which may be a mistake. We'll find out as we go. Luckily, I only have to build one of these, so hopefully any mistakes, I'll at least only have to fix it once. All right, here is my completed build. So I think things went pretty well. Definitely more labor intensive to build this way. Luckily, I have some experience building with point-to-point, other pedals, and also tube amps. And so I have some experience just sort of dealing with the physical nature of components, which you have to think about in a whole different way when components are supporting other components, when the physical shape and size and dimensions matter beyond the footprint that you would just put on a PCB. When you have to think about that, it changes the way you build. And there's a lot of like temporary fixturing you saw with the poster tack that was necessary in order to hold things up, to get it then sort of tack soldered in and make sure, you know, when you put stuff in, you have room to fit other components that are going to connect at junctions in between. So you do really have to think a whole different way about building. Some things I'd improve if I were to do this again, this bus wire here it's pretty straight, but it's not as straight as I like, and it's visible that there's a little kink right here. Straightening bus wire is not easy. There's a couple different methods, one of which is to put one side of the bus wire in like a drill and hold the other end with needle nose pliers and then twist up the wire. It does make a really straight bus wire, but it also twists the wire, literally twists it and work hardens it and makes it really brittle. I don't usually like that method because I don't want to weaken the bus wire, especially in a situation like this where it is mechanically supporting other components. The other method is what I did, which is to just put a hole about the size of the bus wire through like a 2x4 and then put one side in the drill and just spin it and pull it through the 2x4. It's not actually twisting the wire itself. The wire is just sort of rotating inside the hole in the wood, which does straighten it out, but it's not perfect. And so there is a little kink there that kind of bugs me. The other bus wire here, this one looks pretty good. I had to deviate from the design a little bit in terms of having these two capacitors line up, which is visually part of the other design. Also, the outside lead of the output cap here isn't meeting these two resistors in the center, which is part of the original design, the picture I was referencing. And you know what I think would be the solution is to bring down this bus wire a bit down into this gap here so that there's more room for this capacitor. These two caps could sit on top of each other and this resistor could come down, so this would actually meet in between these two in the middle. I was a little bit concerned about the 1/4" jacks here being a different design, but it worked out. You can see here it's pretty tight between the input jack wire and the tang here for the input jack. It seems like it's rubbing on there. It's actually not touching. It's very close, but it's not actually touching there, and also that part of the arm here doesn't move that much, so it's not hitting that. I could have pushed that wire further into the corner, but then it would have been at an angle coming into the lug here for the input jack, and so I opted to keep it 90 degrees. The input capacitor to the circuit, I kept it in the backwards position. Like I covered in part 1, technically this capacitor should be flipped around so that the positive side of the cap is facing the circuit, which would have a slight bias, DC bias, positive DC bias voltage going into the circuit. We saw it on the breadboard. It's less than a volt. It probably doesn't matter for the longevity of the cap. I'm not really worried about that. I think definitely the hardest setup was these two resistors here because you have this resistor floating on top of this bus wire, which means I can't really get any of that poster tack in between to hold it in place. And this resistor here needs to line up straight with this pot, but also bend up and at an angle to meet this resistor. So this was definitely the hardest setup here. If I was going to build a batch of them, I would create some fixture to help me do this, not just kind of freeform it. The poster tack definitely came in handy. It provided like a temporary fixture, like a scaffolding essentially for the different components to make sure stuff sat in the same place, so I could come in and tack solder it and give it the strength. And then I could always go back and shore up those solder connections later when I had other stuff holding up from the other side. The little cap here, this bridges across the collector and base of Q2. I didn't have, this is the only 470 picofarad axial cap I had, are these silver film caps. Not the same as the original pedal, those used multi-layer ceramics. There shouldn't be any difference, it's still a 470 picofarad cap, and like I said before, I don't really think there's much tonal differences just between different styles of cap, especially not in that position. The one other thing that sort of bugs me is each of these potentiometers have a slightly different torque to them. The drift knob here is fairly easy to turn, the texture is somewhere in the middle, and the swell is pretty tough to turn. I did try dripping a little bit of deoxit into these two pots here, and it does get easier to turn, but the deoxit eventually evaporates and then it's back to being kind of stiff. It's not anything that's wrong with the potentiometer, it's just the viscosity of the lubrication they put in there to keep the carbon track and the different metal components in there from oxidizing and keeping them fresh. It is just annoying when you turn each pot and they all feel a little bit different. Other than that, I'm pretty happy with the build, so I say we throw the back door on here and hook it up to an amp and see how it sounds. All right, got the pedal here hooked up for a listening test. So I have a Telecaster with a humbucker in the bridge. I've got a modded Bassman style 1x12 combo amp. I've got an SM57 pointed right on axis at the cone. We're gonna just have a listen and see what the pedal sounds like. Compared to the part one where we did the breadboarding tests, this has different pot values. So we're definitely expecting different function, at least from the sweeps of the pots. We also have carbon comp resistors, so good chance we're gonna get a little bit more noise. Other than that, we'll just see how it sounds. So this is the clean sound. And here's the pedal. All right, so definitely different functions. The texture knob has a good range. As we saw on the breadboard, depending on the HFE of Q1, the texture knob could either not work at all for a good part of the sweep or not do much if the HFE is really high. In this case, it works pretty well where it gets nice and spitty as you turn down the texture knob, and only really at the right end, the past the 9 o'clock, actually 8 or 7 o'clock position, does it actually really just start to drop out. And we'll try single coil. Yeah, not a huge difference there. I think this humbucker on this is pretty weak, so especially if you can hear where the texture knob drops out, but if you had active pickups, this would probably push it even to the bottom. It was still driving enough. I'm gonna try turning up the drift knob. That's where, the drift knob, that's where you get your full rip, roar, and fuzz. So I'm going to try pulling down my guitar volume now. We'll see how that sounds versus turning down the drift knob. Yeah, so that was moving between full-on guitar volume and then back to like 5 or so. And now let's turn down the drift knob, we'll see how that compares. So same sort of idea. I think it stays a little brighter with the drift knob than versus the guitar. There's also, I think this is a audio pot, I believe it is, and there's a lot of change right here at the end. A linear pot might work a little better here for this specific combination of components. Last thing I want to do just to have a little bit of fun is I'm just going to turn on the reverb on this amp. It has built-in reverb and I almost never use it because it doesn't have like a recovery stage like a normal Fender does for reverb, so it's quieter, but I'm going to turn it on just so we get a little wetter sound, something that'll be a little more natural sounding. I realize that these videos sound kind of harsh because there's absolutely no wetness to the sound at all. It's just dry in your face fuzz. So we'll just try that, just have a little bit of fun. All right, so that wraps up my build series, recreating the Zo pedal, which is the modified Zonk 2 built by Reeves Electro. If you are interested in owning this pedal, it will be available for sale. All the proceeds will go to humanitarian aid in Gaza. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing. I'm Joe from Graybench Electronics. Thank you for watching.